Greeting my data science friends. This video is going to talk about the replicate command in R. The replicate command is a function command that replaces a do loop or a for loop or a while loop, and it's very efficient and very powerful. So all of the things that we can do with the replicate command, we could code by using a for loop or a do loop or a while loop. But this R command saves us a lot of time and efficiency and uses the best choice when we need to repeat some certain tasks. So let's kind of look at a similar example to what you find in section 13.2, and I want to point out the importance of the use of this replicate command. So I have a bag of marbles, and I'm going to choose a little bit different than what the textbook in section 13.2 chooses, but I'm going to have 4 marbles in this bag: a red one, another red one, a green one, and a blue one. So 50% of the marbles are red, 25% are green, and 25% are blue. And so I have this bag, and I check that. I have bag red, red, green, blue in my bag. And I want to sample the bag. I want to pull out 4 samples out of the bag. And so, of course, I suspect I'm going to get 2 red and 1 blue and 1 green, because this is without replacement. And so if I repeated that experiment, I expect to get the same thing: 2 red, 1 blue, and 1 green. But you'll notice that those are in different order because it's randomly being done. But without replacement, each time, by the time I get to the end of my 4 selections, there's only 1 marble left. And so that 1 marble left, each time, we know we're going to get 2 red, 1 green, and 1 blue in some order. So if I did it another time, this time I have green first, then red, then blue, right? But again, 2 red, 1 green, and 1 blue. So obviously, I don't want to keep pushing this over and over and over again to show the different combinations that I could get of the 2 red, the green, and the blue. So I want to use this replicate command. So I'm going to make n equal to 100. And then when I do that, now I can use the replicate command. So I'm going to call it the draw is equal to replicate, and replicate n number of times, and then I tell it what to do. So here I'm going to sample the bag, and I'm going to sample the bag 4 times. And so now I've done this, I've made this list of things called draw that has all of these results 100 times. And you see, if I just look at draw, I get this big, long, very ugly looking result that doesn't make a lot of sense. And so our textbook suggests that what we do is look at this data in a much, much cleaner way. And that is a huge emphasis in data science, is you as the data scientist, you as the technician of this data, are going to be responsible for putting the data in a form that decision makers can easily read. And so that's really a big part of what we're doing in data science, is how do I get the results, this draw results, which is overwhelmingly ugly and hard to read. How do I get it into a form that's easy to understand for anyone to see? So the table works really good. So table, let's call it draw table. I call it draw table. That's equal to the table command, and I put in my results from before the draw. So when I do that, now I've made this thing into a much, much cleaner result. And so you see that I have, my results are no surprise. I have 2 times 100 red, and 1 times 100 green, and 1 times 100 blue. And so nothing surprising there, right? That's exactly what I would expect to see. 50% red, 25% green, and 25% blue. Because again, in each draw, I've drawn exactly all of the marbles out. I have no choice. Okay, so that's not particularly interesting. So now I want to do this Monte Carlo simulation, right? And so everything is going to be the same, except for now, when I draw, I'm only going to draw 1 out of each bag. And so I'm going to do that still n number of times, right? So I'm still doing that 100 times. So now, if I looked at just the draw, I get a much cleaner looking version of that draw because I'm only drawing 1 thing out of each 100 choices. But still, this is cumbersome and hard to read, so I'm going to use that table situation again where I put it into a table. And then I want to report the table, so this is what my table looks like. And so now my results are out of 100, right? So I have 46 out of 100 red, which is theoretically should be 50%, and 25% green, which theoretically should be 25%, and 29% blue, which again theoretically should be 29%. Our textbook author proposes that we use this prop table command, does the calculations for us, right? Of course, we could do these in our head, but this prop table, the proportions of the entries of the table calculated for us is nice. So if I want to use this Monte Carlo simulation on a much, much bigger data set, I'm going to use n equals 10,000, right? So now I'm going to do, instead of 100 simulations, I'm going to do 10,000 simulations. And I suspect that these numbers of blue and green and red should get closer to the theoretical probabilities of 25, 25, and 50. So let's see what happens. I instead do 10,000 replicas of my Monte Carlo experiment, and I draw 10,000 samples of 1, and I make this draw table, and I look at the draw table, and sure enough, that seems to be closer, but let's look at the actual proposition or proportions of the draw table. And I see that I've got here close to 50%, close to 25%, and close to 25%. And if I did exactly the same experiment again, so I did completely starting over, exactly the same experiment again, you would see that the values are slightly different, right? The first time we did it was 25% blue, 25.5% green, and 49.5% red, which is slightly bigger than before. And if I did it another time, I would have another result and another result that show these theoretical probabilities. And the interesting thing is, I could do a replicate of this whole process over and over and over again, right? I could use the replicate command to do this process 10, 15, 20 times. So this replicate function is extremely powerful and very useful in data science when we're running not only Monte Carlo simulations, but many, many, many simulations. And hopefully this replicate command will be part of your repertoire as a data scientist.